Alright, so let's talk about how Archimedes approximated pi. If we think about a circle, if we fit a polygon into this circle, then if we measure the perimeter of this polygon, then we can approximate pi. And so let's start with a regular hexagon. Now let's make this a circle of radius 1. And we know the circumference of it is 2 pi. But let's try to come up with an approximation starting with a hexagon. So these are both 1 because they're both radii of the circle. Now, the thing to recognize here is that all 6 of these triangles are the same. So that means each of these angles is going to be 60 degrees, which means that these triangles are all equilateral. So this side length is a 1 as well. So, let's see, for a 6-sided shape is going to be 6 times 1, which is 6. Now, this is approximately the circumference of our circle, which means that pi is approximately 3. But I think we can do better. Our next step now let's focus on this triangle here. If I bisect this angle, meaning I cut the angle into 2 equal parts, and then I connect these corners here. And if I do that for every one of these equilateral triangles, then what I actually form is a 12-gon. And the way to see that is I turn every triangle into 2 triangles, so I end up with 12 triangles. So I end up with 12 straight sides. So what I'm after here is a way to approximate C12. But to do that, I need these lengths. So let's take a look at what we have. I'm going to draw this triangle in a blown up form. So what we end up with is this. I'll call this distance that we're after S. And both of these are of length 1 because they're both radii of the circle. And if I draw a perpendicular here, it's the same as this line here. So it's at a right angle. What that means is that I also know that I also know this length. This length is 1/2 because it's half of this side length that was 1. Now here it's a bit unclear, but 1 is this whole length. Let's call this distance x. And so this distance is 1 minus x. So we can use this triangle here to get 1 minus x using the Pythagorean theorem. You good? Okay. So we know that 1 squared is equal to 1/2 squared plus 1 minus x squared. This is 1/4. And if I subtract 1/4 from both sides, we get that 1 minus x squared is 1 minus 1/4 which is 4 minus 1 over 4, so 3 over 4. And so then 1 minus x must be the square root of that. And I'm only taking the positive square root because I know x is that 1 minus x has to be a positive number. And so then x is 1 minus the square root of 3 over 2. But now I can use the Pythagorean theorem again to get s. So s squared is 1/2 squared plus x squared. So we get 1/2 squared plus 1 minus root 3 over 2 squared. Well, this is 1/4. And here, when I need to expand this binomial. And I'm going to use this rule. And if you want to get that on your own, you can just think of it as a plus b times a plus b. And you can FOIL it out. So first, outer, inner, and last. Multiply everything out, add up what you can, and what you should end up with is this right here. So then we're going to end up with a 1 minus root 3 plus 3 over 4. So if I look at the 1 over 4 plus 3 over 4, that's the same as 4 over 4, so that's a 1. Add it to the 1 I already have, and I get 2 minus square root of 3. And so that's what s squared is. Now to get s, we just take the square root. So it's the square root of 2 minus the square root of 3. So that's one side of our 12 gone. So C12 is going to be 12 times that. And so, of course, we're approximating that as 2 pi, which means that pi is approximately 6 times the square root of 2 minus root 3. That value is about 3.106. So it's closer to pi than the approximation of 3 that we had before. Now the next iteration would be to go up to 24 sides using the same methodology. I'm not going to do that because that's part of your homework, but I hope that this short video has given you an idea of how you can proceed with that part of the homework.